From bone-jarring seats to steering systems that fought back, American farming has come a long way from the brutal days of early mechanization. Today, we're counting down 12 tractor features that farmers absolutely despised. Innovations that seemed brilliant on paper but turned into nightmares in the field. These are the designs that broke bodies, tested patience, and eventually disappeared into the dust of history. This is the story of progress, written in sweat, pain, and hard-learned lessons. Number 12, unpadded metal seats. Picture spending 14 hours straight on a slab of unforgiving steel. That was the reality for farmers, from the 1900s through the 1950s, when tractor seats were nothing more than flat metal platforms bolted to the frame. The Fordson Model F, early Massey Ferguson tractors, and countless other machines came equipped with these torture devices that manufacturers somehow called seats. There was no suspension, no padding, and absolutely no mercy. Every bump in the field transmitted directly through the steel into your spine. Farmers developed chronic back problems that plagued them for life. The vibration from the engine combined with the jarring impacts from uneven ground created a punishment that lasted from sunup to sundown. In winter, that metal seat became an ice-cold plate that sapped warmth from your body. In summer, it transformed into a scorching griddle that could burn through denim. Some farmers tried wrapping burlap sacks around the seat or fashioning crude cushions from old feed bags, but nothing really helped. The steel seat was a constant reminder that tractor manufacturers cared more about simplicity and cost-cutting than operator comfort. By the 1950s, the agricultural industry finally recognized that a miserable operator was an inefficient operator. Suspension seats with padding became standard equipment, transforming the tractor from a medieval torture device into something approaching a comfortable workplace. The old metal seats were relegated to salvage yards, unmourned and unremembered, except by the men whose backs they'd broken. Number 11, gasoline-only engines. In the early decades of tractor development, gasoline was king. Machines like the Ford 9N and the Farmall H relied exclusively on gasoline engines that guzzled fuel at an alarming rate. Farmers watched their operating costs climb every season as they burned through gallon after gallon of expensive gasoline. The problem went beyond just cost. Gasoline engines couldn't deliver the low-end torque that heavy agricultural work demanded. When pulling a plow through heavy clay soil or dragging a loaded wagon up a hillside, these engines struggled and strained, forcing operators to downshift and crawl along at speeds that made every task take twice as long as it should. The fuel economy was abysmal compared to what was coming. A gasoline tractor might burn 8 to 10 gallons in a single day of heavy field work, and that added up quickly over a growing season. The engines also required more maintenance, with spark plugs that fouled frequently and carburetors that needed constant adjustment. Starting a cold gasoline engine on a frosty morning could take half an hour of cranking and cursing. The volatility of gasoline also created fire hazards that made farmers nervous, especially during harvest, when dry conditions turned fields into tinderboxes. Carburetors would flood and spill raw fuel onto hot manifolds, sometimes igniting small fires that could spread if you weren't careful. The high compression ratios needed for efficiency meant gasoline engines were prone to knocking and pinging under heavy loads, which damaged pistons and valves over time. Maintenance intervals were measured in hundreds of hours rather than thousands, with valve adjustments and ring replacements becoming routine expenses. The engines ran hotter than diesel counterparts, which accelerated wear on internal components and made overheating a constant concern during long summer days. Many farmers kept spare spark plugs, condensers, and ignition parts in their toolboxes because breakdowns in the field were just part of gasoline tractor ownership. Everything changed when diesel technology matured in the 1960s. Diesel engines brought massive improvements in fuel efficiency, often cutting consumption by 30 to 40% while delivering superior torque at low RPM. The diesel revolution meant farmers could work longer on less fuel while pulling heavier loads with greater ease. Gasoline tractors faded rapidly from the fields, as diesel proved itself superior in virtually every way that mattered for agricultural work. Today, finding a gasoline farm tractor is like discovering a relic from another era. Interesting as history, but completely obsolete for real work. Number 10, non-synchronized transmissions. The grinding, shrieking sound of clashing gears became the soundtrack of farming from the 1930s through the 1960s. Early tractor transmissions were crash box designs that required perfect timing and a delicate touch to shift without destroying the gears. International Harvester and Ford tractors used these brutal transmission systems that demanded operators master the art of double clutching just to change speeds. Every shift was an exercise in coordination and luck. You had to press the clutch, move the gear lever into neutral, release the clutch briefly to synchronize the transmission speed with the engine, then press the clutch again and jam the lever into the next gear. If your timing was off by even a fraction of a second, the transmission rewarded your incompetence with a horrible grinding noise, and sometimes a complete refusal to engage. Shifting under load was nearly impossible, which meant you had to plan every gear change in advance. Approaching a steep hillside with a plow, you better be in the right gear before you start climbing, because trying to downshift halfway up meant stalling out and sliding backward. The wear and tear on these transmissions was enormous. Inexperienced operators could destroy gears in a single season of ham-fisted shifting. Even skilled farmers wore out synchronizers and clutch assemblies at an alarming rate. Teaching a young farmhand to operate a crashbox transmission was an exercise in patience that tested even the calmest father's nerves. The sound of grinding gears echoing across the fields announced to everyone within earshot that someone was learning the hard way. Some transmissions featured gear patterns that defied logic, with reverse positioned where you'd expect third gear or first gear hidden in some obscure corner of the shift pattern. Cold weather made everything worse because the thick gear oil turned into molasses, making it nearly impossible to feel where the gears wanted to engage. Farmers developed their own tricks and techniques, like revving the engine to specific RPM points, or counting seconds between clutch movements. But these methods only worked for the specific tractor you'd learned on. Switching between different makes and models meant relearning the timing all over again, and the first few shifts on an unfamiliar tractor usually resulted in mechanical carnage. The gear lever itself became a weapon during missed shifts, sometimes bucking back so violently that it bruised ribs or smashed knuckles against the console. Repair costs added insult to injury, with transmission overhauls requiring complete disassembly and eating up precious time during critical planting or harvest windows. Many farmers simply limped along with transmissions that jumped out of gear or refused to engage properly because they couldn't afford the downtime for a proper rebuild. The constant stress of worrying whether you'd be able to shift when you needed to turned every field operation into a gamble. Some operators developed such anxiety about shifting that they'd select a single gear at the start of the day and refuse to change it no matter what the terrain demanded. The introduction of synchronized transmissions in the 1960s changed everything. Suddenly, shifting gears became as simple as pressing the clutch and moving the lever. The Synchromesh design matched gear speeds automatically, eliminating the grinding and the guesswork. Later innovations like power shift transmissions made shifting even easier, allowing on-the-fly speed changes without touching the clutch. The old crashbox transmissions disappeared into history, remembered only by farmers with scars on their knuckles from missed shifts and shattered gear teeth. Number 9. Mechanical brakes. Stopping a 4,000-pound tractor with nothing but mechanical leverage and prayer-defined farming danger from the 1920s through the 1950s. The Fordson Model F and early John Deere tractors relied on mechanical brake systems that connected the brake pedal to the brake drums through a series of rods, cables, and linkages. When everything was perfectly adjusted and the brake shoes were fresh, these systems barely worked. When anything was worn or out of adjustment, they became death traps. The fundamental problem was simple physics. Mechanical brakes relied entirely on the operator's leg strength, amplified through mechanical advantage. On level ground with a light load, you might be able to stop in a reasonable distance. Approaching a hillside with a loaded wagon behind you, those mechanical brakes became suggestions rather than commands. Farmers learned to downshift early and use engine braking because they knew the mechanical brakes couldn't be trusted. Cable-operated systems stretched over time, creating more and more pedal travel before the brakes even began to bite. Rod-actuated systems developed slack at every pivot point, turning a crisp brake response into a mushy, unpredictable affair. The brake shoes themselves wore rapidly, and many farmers simply didn't maintain them properly because replacement meant a day of work for marginal improvement. Runaway tractors killed and injured farmers every year. A tractor creeping down a hillside would pick up speed gradually, and when the operator finally stood on the brake pedal with all his might, nothing happened. The tractor just kept accelerating until it crashed or rolled over. Hydraulic brakes arrived as standard equipment in the 1950s and transformed tractor safety overnight. Hydraulic fluid transmitted braking force instantly and equally to all wheels, multiplying the operator's leg pressure into genuine stopping power. Suddenly, a tractor could actually stop on command, even on hills, even with heavy loads. The mechanical brake era ended not with nostalgia, but with relief that farmers no longer had to gamble their lives every time they pressed the brake pedal. Number 8. Manual lift implements. Before hydraulics revolutionized farming, attaching and lifting implements meant pure human muscle and misery. Throughout the pre-1940s era, farmers using early Allis-Chalmers and Ford tractors had to physically wrestle plows and cultivators into position, then manually crank them up and down at every turn. A bottom plow could weigh 300 pounds or more, and lifting it out of the ground at the end of a row meant grabbing a lever and hauling with every ounce of strength you could muster. The process wore farmers down throughout the day. You'd plow to the end of the row, haul back on the lift lever while the tractor was still moving, turn around, and drop the plow back into the dirt for the return pass. 30 times per hour, hour after hour, day after day during plowing season. Your back screamed, your shoulders burned, and your hands developed calluses on top of calluses. Older farmers and smaller operators simply couldn't generate enough force to lift heavy implements, which limited what equipment they could use. Some implements used screw jack systems that required cranking a handle around and around to raise the tool. This was slightly easier than direct lifting, but took so long that it killed productivity. You'd spend 5 minutes at the end of every row, cranking your cultivator out of the ground, turning the tractor, then cranking it back down. By the end of the day, your arm felt like it was about to fall off. The mechanical advantage of these manual systems was minimal at best, meaning you were essentially deadlifting hundreds of pounds of steel and soil with nothing but leverage and determination. Spring rains made everything exponentially worse because wet clay would cake onto plow bottoms, adding another 50 to 100 pounds of mud that had to be lifted at every turn. Farmers developed chronic injuries that plagued them for decades, with herniated discs and torn rotator cuffs becoming occupational hazards that ended careers prematurely. The physical demands meant that family farms often struggled during transitions when aging fathers could no longer handle the manual labor, and sons weren't yet strong enough to take over completely. Women were effectively excluded from operating many types of equipment simply because the manual lift systems required upper body strength that made the work impossible for most female operators. Harry Ferguson's three-point hitch with hydraulic lift, introduced in the 1930s and standardized by Ford in the 1940s, eliminated all this suffering with elegant simplicity. A touch of a lever sent hydraulic pressure to a cylinder that effortlessly raised implements, weighing hundreds of pounds. The operator could lift, lower, and precisely control implement depth without ever leaving the seat or breaking a sweat. The hydraulic revolution meant smaller operators and older farmers could handle equipment that had previously been beyond their physical capability. Manual lift implements disappeared so completely that young farmers today can barely comprehend how brutally physical farming used to be. Number 7. Exposed gears and belts. The early tractor era was a meat grinder waiting to happen. Machines from the 1910s through the 1930s, including models like the Rumely oil pull, featured exposed moving parts that turned innocently curious moments into life-changing tragedies. Gears meshed in plain sight, belt drives spun inches from the operator's position, power takeoff shafts rotated at 1,000 RPM with nothing but air between them and human flesh. Farmers lost fingers checking belt tension while machines were running. Loose clothing got caught in exposed chains and dragged operators into machinery that had no emergency stop and no mercy. The agricultural industry's attitude towards safety in those days was essentially non-existent. Manufacturers built tractors to be simple, powerful, and cheap. Protective guards added cost and complexity, so they simply weren't included. The result was a generation of farmers who learned caution through tragedy, either their own or that of a neighbor who got too close to the wrong spinning part. Children were especially vulnerable. Farm kids grew up around machinery and developed a dangerous familiarity that led them to stick hands where they shouldn't go. Stories circulated through rural communities about boys who lost arms to PTO shafts or got scalped when their hair caught in an exposed pulley. The movement toward mandatory safety shielding gained momentum slowly through the mid-20th century. State regulations began requiring guards on certain implements. Insurance companies refused to cover injuries from obviously unprotected machinery. Manufacturers started including basic shields and guards as standard equipment, not out of altruism, but because lawsuits and bad publicity were costing them money. By the 1960s, exposed moving parts had mostly disappeared behind steel guards, plastic shields, and safety interlocks. Modern tractors feature layers of protection that make it nearly impossible to contact moving parts during normal operation. The old exposed gear tractors remain as museum pieces and reminders of an era when farming was even more dangerous than it is today. Number 6. Hand crank. Starting. The hand crank was agriculture's version of Russian roulette. From the early 1900s through the 1940s, starting a tractor meant grabbing a steel crank, inserting it into the engine, and hoping the kickback didn't break your arm. The Fordson Model F and early International Harvester tractors relied entirely on this dangerous method because electric starters were too expensive and too fragile for farm use. Every morning became a test of courage and technique. The proper method required specific hand positioning. You were supposed to push up on the crank with an open palm, thumb alongside your fingers, rather than wrapped around the handle. This way, if the engine kicked back, the crank would fly out of your hand, rather than reversing direction and smashing your wrist. But knowing the proper technique and remembering it at 5 in the morning in freezing weather were two different things. Farmers wrapped their whole hand around the crank because it felt natural, and when the engine backfired, the spinning crank reversed instantly and violently. Broken wrists were common. Shattered thumbs happened regularly. Occasionally, a vicious kickback would break someone's jaw or knock them unconscious. The injuries were so frequent that rural doctors became experts at setting broken bones caused by tractor cranks. Cold weather made everything worse. A cold engine was harder to turn over, requiring more effort and multiple attempts. The magneto timing could be temperamental, and if it fired too early, the kickback was savage. Some mornings, starting a tractor took 30 minutes of cranking, cursing, and dodging the spinning handle. Older farmers and women often simply couldn't generate enough force to crank over a cold engine, limiting who could operate the machinery. Electric starters became widespread by the 1940s, and the change was revolutionary. Push a button, and the engine spun over reliably with no risk to life and limb. The hand crank disappeared so quickly that within a generation, young farmers couldn't believe their grandfathers had started tractors that way. Today, finding a hand crank tractor is like discovering a dangerous antique. Fascinating but terrifying. Number 5. Manual steering. Imagine wrestling a 2-ton machine through sticky clay soil, using nothing but your arms and determination. That was everyday reality for farmers operating tractors, like the Ford 8N and Farmall M from the 1900s through the 1950s. Manual steering on these machines required genuine physical strength, and a long day in the field left operators with arms that trembled from exhaustion. The steering effort varied wildly depending on conditions. On dry, firm ground with the front wheels rolling freely, manual steering was merely tiresome. In wet, heavy soil, where the front tires wanted to knife sideways, steering became a full-body workout that left you gasping. Every turn at the end of a row meant hauling the steering wheel through multiple rotations, fighting the mechanical advantage of the steering box against the resistance of tires carving through dirt. Smaller operators and older farmers sometimes struggled to generate enough force to turn the tractor in heavy conditions. The steering wheel became a torture device during long days of cultivation when you made hundreds of small corrections to keep the implement tracking straight. Your forearms would burn with lactic acid. Your shoulders would ache from the constant tension. By evening, you could barely hold a fork at dinner because your hands were so cramped. The introduction of power steering in the 1950s changed farming as dramatically as the tractor had changed agriculture a generation earlier. Hydraulic assist meant a light touch on the wheel produced effortless turning, regardless of soil conditions or load. Suddenly, anyone could steer a tractor all day without exhaustion. Older farmers could keep working instead of retiring because the physical demands dropped dramatically. Women entered tractor operations in greater numbers because upper body strength no longer determined who could drive. Power steering became standard so quickly that manual steering tractors were considered primitive within a decade. Today, modern tractors feature steering that's so light and responsive that operators sometimes overcorrect because they're used to fighting the wheel. The manual steering era belongs to history, remembered only by farmers with chronic shoulder problems and a healthy respect for just how hard their fathers worked. Number 4. Exposed operator stations. For the first 7 decades of tractor development, operators sat completely exposed to every element nature could throw at them. The concept of an enclosed cab simply didn't exist. From the Fordson Model F through tractors of the 1960s, farmers endured blazing sun, driving rain, choking dust, and bone-chilling cold with nothing but their clothing for protection. The open operator station meant every day was a battle against the environment. Summer fieldwork turned tractor seats into blast furnaces. The engine heat radiated upward, while the sun beat down from above, and there was no escape. Farmers developed skin cancer from decades of sun exposure. Dehydration was a constant danger during hay season and harvest. Dust from field operations created respiratory problems that plagued farmers for life. Plowing dry ground meant spending the day in a cloud of pulverized dirt that coated everything and infiltrated your lungs with every breath. Rain and hail pelted operators with no mercy. Some farmers rigged crude umbrellas or canvas tarps to provide minimal protection. But these were hopeless against wind and created new hazards by blocking vision. The real killer, though, was the lack of rollover protection. When a tractor tipped sideways on a hillside or reared backward from a stuck implement, there was nothing between the operator and the crushing weight of the machine. Farmers died by the hundreds every year when tractors rolled over and pinned them underneath. The tractor would tip slowly enough that you knew what was happening, but too fast to jump clear. Then 3 tons of steel would land on you, and that was that. The introduction of ROPS, rollover protective structures, became mandatory on new tractors manufactured after October 1976 in the United States. These 2-post or 4-post roll bars created a protective zone that kept the operator from being crushed during a rollover. Later, fully enclosed cabs combined rollover protection with climate control, dust filtration, and noise reduction. Modern tractor operators work in air-conditioned comfort with stereos and suspension seats. The exposed operator station era ended, and not a single farmer mourned its passing. Number 3. Tricycle front end. The narrow front-end design seemed brilliant in theory, but terrifying in practice. From the 1930s through the 1970s, tractors like the John Deere Model A and Farmall H featured tricycle front ends with 2 closely spaced wheels that gave these machines the agility of a sports car and the stability of a unicycle. Row crop farming drove the design. That narrow front end could slip between corn rows without damaging plants, allowing for precise cultivation. The problem was that narrow track made these tractors dangerously prone to tipping over sideways. The physics were brutally simple. A wide wheelbase provides stability. A narrow wheelbase creates a tipping hazard. Tricycle front-end tractors had a narrow rear track too, which meant the entire machine balanced on a relatively small footprint. Anytime the tractor crossed a slope, the center of gravity wanted to continue straight down the hill, while the tires tried to follow the ground. The result was constant side loading that pushed the tractor toward rolling over. Farmers learned to approach hillsides at an angle and to never ever turn sharply while on a slope. But sometimes terrain forced you into a tight turn on uneven ground, and that's when tricycle tractors showed their deadly nature. The tractor would start to lean, and once it passed the tipping point, there was no stopping it. The machine would roll over slowly and deliberately, giving you just enough time to realize you were probably about to die. Thousands of farmers were crushed under tricycle front-end tractors. The combination of a high center of gravity, narrow wheelbase, and lack of rollover protection made these machines killing devices waiting for the right conditions. Front-mounted implements like loaders made the problem even worse by adding weight up high and far forward. Even on flat ground, hitting a hole or a soft spot with one rear wheel could cause a sudden tilt that became an unstoppable roll. The agricultural industry's solution was the wide front axle. Spreading the front wheels apart dramatically improved stability without sacrificing much maneuverability. By the 1980s, tricycle front ends had virtually disappeared from new tractor production. Farmers retrofitted older machines with wide front ends or simply retired them. Today, seeing a tricycle front-end tractor in active field use is rare. Most sit in museums or at antique shows. Beautiful examples of engineering that looked past safety in pursuit of functionality. Number 2, steel wheels. Before rubber tires revolutionized agriculture, tractors rolled on steel wheels that punished both the machine and the land. The Fordson Model F and early John Deere tractors came equipped with fabricated steel wheels, featuring cleats or lugs that were supposed to provide traction. What they actually provided was a bone-jarring ride that shook fillings loose and turned every field into a minefield of compaction and rutting. The wheels themselves were engineering marvels of the wrong kind, heavy, expensive to manufacture, and completely unsuited for their intended purpose. Steel wheels destroyed soil structure. Those cleats concentrated enormous pressure into small contact points, compacting the soil and creating hardpan layers that impeded root growth and water infiltration for years afterward. In wet conditions, steel wheels would sink deep into mud and create ruts that turned fields into washboard nightmares. The wheels would spin freely without gripping, forcing operators to add more and more weight to the tractor just to maintain traction. This extra weight made the compaction problem even worse, creating a vicious cycle of destruction. The ride quality defied description. Every cleat hitting the ground transmitted a sharp impact directly through the frame to the operator's spine. Crossing a field felt like riding inside a paint shaker. The constant vibration loosened bolts, cracked castings, and wore out bearings at an alarming rate. Tractors needed constant maintenance, just from the abuse inflicted by their own wheels. Road travel on steel wheels was illegal in many jurisdictions because the cleats tore up pavement and created hazards for other vehicles. Farmers who needed to move tractors between fields had to load them onto trailers or add removable rubber pads to the wheels. The arrival of pneumatic rubber tires in the 1930s changed everything overnight. Rubber provided superior traction through a larger contact patch that distributed weight over a wider area. The pneumatic cushion absorbed impacts and vibration, making the ride tolerable. Soil compaction dropped dramatically. Fuel efficiency improved because rolling resistance decreased. Speed increased because the tractor could finally travel faster than a walking pace without shaking itself apart. Steel wheels disappeared so completely and so quickly that within 10 years, they were considered hopelessly obsolete. Farmers cut the steel wheels off old tractors and welded on rims for rubber tires, creating countless modified machines that served for decades more. Today, steel-wheeled tractors exist only as showpieces and museum exhibits, reminders of an era when farming was even harder than it had to be. Number 1, Crabsteer four-wheel drive. The case, 2670 and 1370, represented the agricultural industry's strangest experiment in steering geometry. These 1980s four-wheel drive tractors featured crab steering, a system where the rear wheels turned in parallel with the front wheels, causing the entire tractor to move sideways, rather than pivoting around a central point. On paper, crab steering offered advantages for specific applications like working on hillsides. In reality, it confused operators, felt unsafe, and disappeared faster than almost any other tractor feature in history. The concept seemed sound. Traditional articulated four-wheel drive tractors pivoted in the middle, which changed the relationship between the tractor and the implement during turns. Crab steering maintained that relationship by having all four wheels turn in the same direction, letting the tractor slide sideways while moving forward. This theoretically allowed better control when pulling implements through contoured terrain. The execution, however, was a nightmare. The electronic steering potentiometers that controlled rear wheel position were temperamental and prone to failure. When the system malfunctioned, results ranged from annoying to terrifying. Farmers reported instances where the rear wheels would suddenly steer toward the ditch while traveling down roads with implements in tow. One operator described the rear end steering into oncoming traffic while he fought to maintain control. The tractor's computer had decided the rear wheels needed to turn, and there was nothing the driver could do to stop it, except shut down the entire system. Even when working properly, crab steering felt wrong to operators. The tractor moved in ways that violated every instinct developed from years of driving conventional machines. Making a turn required thinking 3 steps ahead about what the rear wheels were going to do. The cognitive load was exhausting, and many farmers simply disabled the rear steer function and operated in front-wheel steer mode only. This defeated the entire purpose of the expensive system. The rigid frame design that crab steering required also created maintenance headaches. Articulated four-wheel drive tractors could flex in the middle to absorb stress. Rigid frame crab steer machines transmitted every shock and strain through the frame and drivetrain, leading to component failures and expensive repairs. The transmissions and clutches were undersized for the power and loads involved. Farmers who needed genuine four-wheel drive capability bought articulated machines from other manufacturers. By the mid-1990s, Case had abandoned the crab steer concept entirely. The 4690 and 4694 became cautionary tales about the dangers of overcomplicating tractor design. Farmers who owned these machines either learned to live with their quirks or traded them for conventional articulated four-wheel drives. Today, finding a working crab steer case is rare. Most have been retired or stripped for parts. The ones that remain are curiosities that represent one of the most interesting dead ends in agricultural engineering history. These 12 features defined an era when farming was more dangerous and physically demanding than modern operators can imagine. Steel wheels that destroyed soil and shook tractors apart, hand cranks that broke arms, tricycle front ends that rolled over and crushed farmers, exposed operator stations that offered no protection from weather or rollovers. Each of these design choices made sense to engineers working within the constraints of their time, but each extracted a terrible cost from the men and women who depended on this equipment for their livelihoods. The fact that these features disappeared isn't surprising. What's remarkable is how quickly farmers abandoned them once better alternatives appeared. The moment rubber tires became available, steel wheels vanished. Electric starters made hand cranks obsolete within a decade. Power steering, hydraulic controls, and ROPS transformed tractors from brutal machines into comfortable, capable tools. Today's farmers work in air-conditioned cabs with power steering, suspension seats, and layers of safety equipment that would seem like science fiction to operators from the 1930s. The progress represents not just technological advancement, but a recognition that farmers deserved equipment that didn't break their bodies while they worked. Which of these features seems most brutal to you? Drop your thoughts in the comments, and if you appreciate the stories behind agricultural history, hit that subscribe button for more deep dives into the machines that built America's farm.